Hi, section 9.6 is on dilations. Dilations is our last type of transformation that we're going to go over. The first three we talked about were translations, reflections, and rotations. And then we did the composition of isometries. All of those, the figures were staying the same shape and the same size. They were just moving to a new location. This is the last one, section 9.6. And it is a transformation that the figure is either getting bigger or smaller. So it's staying the same shape, but it's not staying the same size. So a dilation is a transformation that changes the size of a figure. It can become larger or smaller, and the dilation is similar to its pre-image. So again, its corresponding sides are proportional, not congruent in this case. And you can see here, I guess I forgot to mention before I moved up, the original pre-image is the PQR, in this case, the smaller one. And then the image, the new one, is the P prime, Q prime, R prime. Again, you can see that each side got scaled up by the same amount. Okay, so an enlargement is a dilation when the scale factor is a number greater than 1. It can be a fraction, it can be a decimal, but anything that represents a number greater than 1 would be an enlargement. It can be 1.5 or 3 halves or 5 halves or 2 or 3 or 2.5. Any of those would represent an enlargement. And then a reduction is a dilation when the scale factor is between 0 and 1. So again, it can be a fraction or a decimal, but it could be 1/2 or 1/4 or 3/4, or it could be 0.5 or 0.25 or 0.75, anything that represents a number between 0 and 1. Okay, you can see these two examples. The one on the left is an enlargement. You can see the original A, B, C, D, and then you can see it becomes A prime, B prime, C prime, D prime, and you can see that the figure got larger. And that's why this is an enlargement. And in terms of the scale factor, they're showing you the little formula here, that it's the image over the pre-image. So in this case, again, the image is like the new one. Okay, and the pre-image is like the original or the old one. Okay, so you got to keep that straight to make sure you get that scale factor correct. And that doesn't look very good, my original, so I'm going to rewrite that. So original or old, the one that you started with. So in this case, just be careful with that. In this case, the image length is the new length with the primes, which is 4, and the original or the old length, in this case, is the 2. And then you just want to reduce it down if you can. In this case, we get a scale factor of 2. So every length is getting doubled. And again, that number is a number greater than 1, so it makes sense that it's an enlargement. Over here on the right side, we can see that, again, same formula. The new length is now the 2. The original or the old length is the 8. And then if I reduce that down, I could either write that as 1/4, or I could write that as 0.25 if I prefer. They mean the same thing, so it doesn't matter if you put a decimal or a fraction. Okay, so for function notation, just like the capital T stands for a translation and the capital R stands for reflection and the little r stands for rotation. Now in this case, the D here represents a dilation. The little 2 right here, it represents the scale factor. It has a scale factor of 2. And the triangle ABC is just what is getting dilated or what is getting bigger or smaller. So again, in words here, it says it describes a dilation with an enlargement. Scale factor of 2. So on example 2, it says triangle X prime T prime R prime is a dilation of the pre-image triangle XTR and is the dilation enlargement or reduction. So we can see the original XRT is right here. And then we can see that the new one with the primes on it is the bigger triangle. Okay. So we can see that it got bigger, so we know it's an enlargement. But with the scale factor, you need to be careful. Okay, first of all, we got to be careful that we make sure we go image over pre-image length. And so in terms of this, the pre-image length, I'm going to write that first, is the original length, which is 4. The image, a lot of times people will put that it's an 8, but you have to be careful. The 8 is not the length of the side of a triangle. You have to actually consider the whole length, which is 12. So the new length is 12, not 8. So be careful of that. And 12 divided by 4 gives you 3. Again, a scale factor greater than 1 means it is going to be an enlargement. Okay, so next is just more problems of what we were just doing. Let me try and make that a tad bit smaller. Okay, so same directions as what we just did for number 3, 4, 5, and 6. If you want to try these on your own, that's what we did in class. You could try these. Your writing is an enlargement or reduction, and then writing the scale factor. Then you could come back on to check your answers. So in this case, on number 3, then I can see that the A prime, B prime, C prime is the 8, and then the original A, B, C is the 10. So I know the original length was 10, and then it became 8. So I can tell that one is going to be a reduction because the figure got smaller. And then again, if I go image over pre-image, then I end up with 8 over 10, which reduces down to 4/5. Again, if you write 0.8, that's fine. If you write it as a decimal. Okay, on number 4, I don't see any links. They didn't give it to me, but because it's these dots, it's kind of like graph paper. I can count the spaces, 1, 2, 3, 4, 5, 6. I can count the spaces in the horizontal and vertical directions. This AC has a length of 6. I can see A prime C prime has a length of 3, and A prime B prime has a length of 3. So again, I can see from the ABC, original ABC, down to the A prime, B prime, C prime, it got smaller. So again, it's a reduction. And again, if I go image, the new length is 3. Pick a pair of corresponding lengths. The original length is 6. So that reduces down to 1/2. Or if you write 0.5, that's fine. Okay, on number 5, I can see that AB has a length of 2. And I can see A prime, B prime has a length of 3. So in this particular case, again, the original ABCD is 2. The new one, A prime, B prime, C prime, D prime, is 3. And so this one got bigger, so it's an enlargement. And so in that particular case, then the image is 3 over the original length is 2. And so 3/2 is my scale factor. If you want to write 1.5 as a decimal, that's fine. It means the same thing. Okay. Then on number 10, or number 6, I can see that the original is the XYZ, the big one, and then it went down to X prime, Y prime, Z prime, which is the smaller one. So I can see it's a reduction again. If I think of what the image length is, then it is a length of 5 with the primes. And the original length, you don't want to say 10 because 10 isn't the side of a triangle, but this whole length right here is 15. So that's going to be my bottom number. So again, be careful with that. Don't let it trick you. And if I go and reduce that down, I get 1/3. That doesn't look good. I'm going to try again. On the 1/3. There we go. Okay. So moving right along, last little bit here says to graph the image of each figure under a dilation with the given scale factor. So in this particular case, on a lot of these other transformations, we have graphed the new figure first and then gone back and written the new ordered pairs. For the dilations, I think it's easier to figure out what the new ordered pairs are and then go back and figure out what the new ordered pairs are and then graph it. Okay, so in this particular case, I need to know what the original ordered pairs are first. You can see that A has already been done for us. We can see that's the point -40. I can see B is at the point 30. I can see C is at 2, -5. And I can see D is at -5, -5. All right. So up here, you can see they already did A for me. That little 2 means that it's a scale factor of 2. You can see it took the ordered pair and multiplied each part of the ordered pair by 2 to get the new ordered pair, which is -80. So if I go ahead and graph that new length, -80 right here is where my A prime is, my new A. Okay, I need to figure out where my new B, my new C, and my new D are going to be. So I know that B is at the point 30. So I'm going to go 3 times 2, and I'm going to go 0 times 2. And that's going to give me the ordered pair 6, 0. All right, the C is 2, -5. So I've got 2 times 2 and -5 times 2. And that gives me the point for -10. And then my new D, my original D is -5, -5. So I've got -5 times 2, and I've got -5 times 2 again. And that gives me -10, -10. So if I go and plot these new points, I've got my 6, 0 is my B prime. I've got 4, -10 for my new C prime. And I've got -10, -10 for my new D prime. I go ahead and graph that. I should see it's still the same shape, but it's not the same size anymore. It just got bigger. All the side lengths just got doubled. Okay, same idea on number 8. If you want to go ahead and try this one by yourself, feel free to do that. And then you can get back on and check your answers. That's what we did in class, is they did some practice on their own. So again, I need to know what the original ordered pairs are. So in this case for D, I've got the point -6, 2. I've got the point 6, 4. And I've got the point -2, -8. Okay, and so same idea here, except for we're halving all the lengths, or multiplying by 0.5, or dividing by 2, however you want to think about it. So if I start with D, I've got -6 times 1/2, and I've got 2 times 1/2, and that's going to give me -3, 1. Okay, next one, E is at 6, 4, so I've got 6 times 1/2 and 4 times 1/2, and that gives me the point 3, 2. And then last one on F, I've got -2 times 1/2 and -8 times 1/2, and that gives me the point -1, -4. Okay, so now I just need to plot these new points. And I can see that the new D is at -3, 1. So there's my D prime. E is at 3, 2. And F is at -1, -4. So there's my F prime. I can connect my dots. And there's my new triangle. All right, so hopefully that helps with section 9.6 and dilations. And just let me know if you have any questions.